Hey guys, and welcome back. This time we're going to talk about polygons. Alright, so you know polygons, you got your triangles, your quadrilaterals, your pentagons, your hexagons, your heptagons, your octagons, your nonagons, all the gons, right? That you might remember from elementary school. But what is a polygon? So a polygon is actually just a closed figure in a plane that's formed by connecting line segments. So all of these line segments are connected endpoint to endpoint, and they intersect exactly two other line segments. So what that means is you have one line segment. At this endpoint, it connects to another line segment. At this endpoint, it connects to another line segment, so that it is a closed figure. There's no openings. These are all not examples of polygons or counterexamples of polygons. The reason being, this one is curved, so polygons cannot have any curved surfaces because curved surfaces are not line segments. It also can't cross in on itself because when that happens, this point right here is connected to 4 different line segments instead of 2. It's only allowed to connect to 2 others, so it can't cross in on itself. This is just a line segment, so it's not a closed figure, and this one is also not a closed figure. So, if we want to kind of give a little bit of terminology to this, so we know what a polygon is. So this is a polygon. This is polygon A, B, C, D, E. And each of the line segments then, so this right here, this here, here, and here, are all called sides. So this is one side of your polygon. Where each endpoint meets the side, or where our sides meet at each endpoint, so at C right here, that's called a vertex. V-R-T-X, vertex. So each one of these points that I have labeled is a vertex. There's one other thing that you'll hear often when we're talking about polygons, and it's consecutive. So if you think the word consecutive, so if you're looking at like ordering things like alphabetically, the person that comes after you is your consecutive, or the person that comes before you is your consecutive because it's in order. So for this, consecutive vertices are then these points right here. So E and D are an example of a consecutive vertice. You could also say A and B or A and E, anything that's close to each other. It's one side away. The same goes for angles. Consecutive angles would be one that comes next to that angle. So A and B, they don't have to be the same angle. They don't have to have the same measurement, but as long as they're only one side away. So those are consecutive angles. And the same thing happens for sides. They're the next side. So this side, the line segment CD, is a consecutive side to the line segment BC. And of course, you can also do the same thing for these. Anyone that's right next to each other. All right? If we want to name, and the other thing we want to do is naming polygons. So when you name a polygon, you have to go in order from one side all the way in a consecutive order. So if you're going to list these vertices in a consecutive order, you can start at any vertex you want. So I like to start at A. All right, so if we start at A, then you can go to one consecutive vertex. So you can go this way or you can go this way. I like to go clockwise, but that's up to you. So going clockwise, E, D, C, and B. All right, so I'm going to give you a question, and I want you to just tell me which one does not work. So these are your choices. A, B, C, D, E, or D, C, B, A, E, or BCAED or EDCBA. Go back and relook at that if you need to. But which one would not be the name for this polygon? All right, the correct answer, which one does not work, is this one. This does not work because BCA, this transition right here, this one works, this does not. That does not work because it's not a consecutive vertice. You have to go consecutively. So if you decide to go this direction, your next one has to be D. All right? So great job, and I will see you in the next video.